Once again, proper introducing myself here. So I'm Fernando Vizcaino. I'm working in a data meaning enablement team, and I'm also an Alteryx ace, right? So of course, I'm contributing a lot on the community. Maybe if you are asking a lot of questions there, or if you're trying to find anything that you're interested with, maybe you have seen me there, but I also have all the certifications. And as I mentioned before, I'm in a serious relationship with Alteryx, and only Alteryx for 7 years. Okay, so today we are going to be talking about expanded server scaling. Okay, the previous one was the introduction to Alteryx Server. We talk about all the components that we have there. We start understand what actually happens when we run a workflow from the back end side of things. Now we're going to take a look how we can start scaling that server, but we have a lot of different sessions coming every Wednesday, actually. So we will talk about installation and deployment, the user side overview, as well the administrative side overview of the Alteryx gallery, but also I'm going to be talking about the APIs if you want to start running your workflows remotely from other applications, and as well as some use cases that we have here, but also the production process and analytical apps. So here, of course, have a whole understanding of what Alteryx, the Alteryx server platform is, but you need to learn how to publish a workflow and all the things that you need to be aware and to keep in mind when you are uploading or publishing any workflow to the gallery. So for today's agenda, we are going to be talking about scaling Alteryx server overview. Here, we're going to be revisiting some of the topics brought on a previous session. And we're also going to be talking about some references for deployment sizing as well. So this we also saw in our previous session, but we're going to be talking in a more detailed manner how to scale your MongoDB, when should you scale, and how can you scale all the methods that you have there for MongoDB, for the gallery, how can you add a new gallery, thinking about the system settings. And that's something that we're going to cover as well in our next session. And everything you need to know about scaling workers, right? Of course, that's for the workers, especially the workers, since this is the one responsible for running all the workflows, we have some benchmark testing and examples as well. And of course, we always need to hear the users' feedbacks, our developers' feedbacks, but how can we start identifying the scaling need in a more statistical way, as well as some tips and tricks about workflow optimization. Because of course, we always want to scale our workers to run more workflows at the same time or faster. But maybe we need to take a look inside of those workflows and see if everything is done the best way possible, right? So let's start here with our overview. So I have a few questions here when we think about scaling, or a few topics. For example, so if your workflow used to run in 5 minutes and now is taking more than 20 minutes to run, or maybe 1 hour, I don't know, or maybe 3 hours, or maybe your workflow never gets completed, or maybe it's taking a lot of time to load gallery pages, or for a user to start selecting the questions from an analytical app. Or you have very critical workflows that needs to run the fastest way possible. Or a group of devs workflows that run really heavier data sets, and maybe it's better to separate them from the whole population of users, because maybe they are using the worker too much. Or you are starting to get worried about server downtime. So how can I minimize or eliminate that? So the first thing here is that maybe the reason is for performance. Maybe it's for you to have more additional web users. So you have more users starting to use Alteryx Server. We have developers creating more and more analytical apps there for our end users to start using. And of course, with that, we start to ask more performance from our gallery node. So the good thing here is that we have only 3 points of scalability. So for us to be able to solve all the problems that we might have there in our environments, we can start by thinking about adding worker, gallery, or database capacity. Of course, for each of those, it serves to a purpose. And for all of those 3, actually, so for the worker, the gallery, and the database as well, if you want a high availability server, you can scale all of them. Maybe you need to be aware of the workflows that are running. You need to keep your workflows up and running, the schedules always working. Or if you have any issue related to the gallery, to the user experience, then you can include one more node there. And also for the database. So if it gets corrupted, or if you want to have, you don't want to experience any kind of downtime, right? So that's one thing that you always need to be aware. But as you can see here, for all of the topics here, the worker always prevails. Because in a way, the workflow is the most important asset inside the gallery. Of course, the users are also the end users and the developers, but the workflow is what everything is all about. So you have the collections, the studios, ways of grouping everything there all together. It's all related to how you are going to be sharing your workflow, how you are going to be collaborating with that workflow. So the idea there is that you have multiple topics or multiple reasons for you to start scaling your worker. And one thing that actually we need to review or revisit once again is what actually these components do inside our own environments. So let's talk about that. So we have here, of course, the designer is connected to your, here it's an example of a single node environment. You have the end users connect to the gallery, and you have here the service layer that is the brain. So your controller is the brain of your processes. It's giving jobs to the worker. It's requesting information from the database and sending to the gallery, for example. But let's talk about the worker first. So it's responsible for the execution of the workflows. Of course, it manages the Alteryx engine, and it's responsible for anything related to outputs, map tiles, and insights. And if you don't remember, insights are those interactive charts that you are able to leverage using the Alteryx server. The second one, the gallery components. So it's responsible for all the user interface, for all the logic, for everything that is displayed there. So every page that you access, all the click that you are actually doing there, the gallery that is managing and translating that to communicate to the service layer. Lastly, we have the database that serves as a persistence layer for everything that you have there, all the workflows, all the jobs, all the results, and all the schedules as well. So everything is being maintained here. So that's why maybe when your environment gets bigger, you have more users there, you will have an increase of information going to your database, and maybe it's better for you to start thinking about scaling your MongoDB database. But before I start talking about that, let us talk about the processes once again. So the idea here is for you to have the whole picture of what is actually happening. So if you have a manual run or an analytical app being used, the idea there is, as you can see, all the components are being used. So if you have more workflows being run, more users accessing the gallery, you are using more of each of the components. So that's why, okay, you have more users, but maybe you need to start thinking about scaling the gallery, or maybe you need to run more workflows at the same time. So it really depends on your own environment, on your own analysis. That's why we have that benchmark that we're going to be talking later, for you to be able to see some examples of how you can test your environment, how you can stress your environment for you to decide what to scale. Okay. And of course, here we have some templates. And once again, it is a template. It's one thing that you always need to be aware here, that all is really dependent of what the users are doing and what the workflows are actually doing as well. So if you have data prep workflows or spatial workflows, it's all dependent of that. So here's only one idea for you to always be aware what you can actually start leveraging here. So if you have, for example, here 20 simultaneous users, so maybe it's better for you to start with a single node environment. But as the number of simultaneous users or simultaneous jobs increases, or simultaneous runs, manual runs of workflows increases, maybe you need to start thinking about scaling your worker. And as the number of user increases, of course, you need to always be thinking about scaling your worker, so to have more power to process your workflows. But now maybe you need to start thinking about your MongoDB strategy. You need to think about offloading that database proper processing that you have there. And of course, as you have an infinite amount of users there, now you need to be aware of the user experience as well. So if you have a lot of analytical apps there, maybe you need to start using a load balancer there. And the idea here is for it to provide a more seamless user experience for all of the users. It doesn't matter if it's the end user or the developer that needs to start sharing the workflows with everyone there. The idea that everything here is customized to provide the best user experience. So what the idea here is to make Alteryx users' lives better, right? So let's start talking about MongoDB. So why do I need to scale? Do I need to scale for performance? Is that the reason? Or do I need redundancy? What is actually my backup plan? Do I have one? More importantly, what is my failover plan? Or do I need to have one failover plan? And when I start using Alteryx, the single node environment, should I start using the standalone MongoDB environment, or can I use the embed one? Because as I mentioned in our previous session, you have two options there when installing your environment. You have the option to use the embed MongoDB, but also the standalone one. So when we think about the embed one, it works great for single node environments, but when you decide to scale, you will need to move to a standalone MongoDB instance. So maybe when you are configuring your MongoDB at the first time, and you are already projecting that you are going to be scaling the database, you are going to be scaling your worker nodes, or that Alteryx will be transformed into a very strong tool for your company, maybe it's better for you to start already configure the standalone, and then you have a more seamless configuration when you go to the replica sets. But once again here, the reasons are always performance, redundancy, failover, disaster recovery, and also the cost. So the cost of your downtime versus the cost of your high availability MongoDB solution. So once again, for beginning environments, it may not be necessary. When you start to have heavier loads there, maybe you need to think about the need of have some more stability, right? And the methods for scaling MongoDB, we have 3 here. So the first one is vertical scaling. So you are adding more CPU, you're adding more storage to your single node environment. And as you can see here, and you already have that experience, is that it's disproportionately more expensive. So as you start to put more and more to a singular system, it's always get more expensive than scaling out, right? But for that, we have the replication one, where you are duplicating your data sets. You are building your failover strategy here, but also the possibility for sharding clusters. So the idea here is that you are scaling horizontally, but also distributing your data over multiple machines. So the idea here for you to distribute, of course, for you to have to start processing things faster as well. So that's one of the idea. And the other idea is for you to have a high availability solution. So for the first one, for the replica sets, how that actually work. So the idea here is that you have your singular database node working as your primary MongoDB node. So if this node fails, what happens there? So the whole platform goes down. And once again, what is the cost of this happening to your company? But if you have replica sets, the idea there is that you have everything on your primary node as well as in your secondaries. So you have the whole persistence there duplicated. That's why it's called a replica. And if the primary one fails, the idea is that one of the secondaries becomes primary now. And of course, when you fix the problem and your node gets restored, the previous primary one, it will start working automatically as a secondary node. Sharding. So I'm not going to go very deep into the subject here, but the idea here, as you can see, you have the replica sets here, of course, a high availability solution, but the idea for sharding is that it is a method for storing data across multiple machines. So what is the idea? One example is that, okay, so you have your original table here, and you have 2 options there, vertical partitions, but also horizontal partitions. And the idea here is fairly simple. As you can see here, we had the same table, but different columns in each of the partitions. And the idea for the horizontal one is that you have different customer in each of the partitions. Of course, when you start using this, you now are able to support very large data sets and reduce the I/O and CPU stress on a single machine. You have a lot of ways, a lot of methodologies here. I'm not going to be covering that, but the idea is that if you have a robust environment there, maybe it's better for you to start thinking about sharding, right? Scaling the gallery moving forward. So the idea here, so when should you scale the gallery? So of course, the first topic to think of there is the number of users accessing the gallery. So the number of workflows, as well as the type of the workflows, the complexity, the amount of workflows. So simple workflows are very straightforward for us to control. But when you start including more complexity to the workflow, so once again, it can be predictive, it can be spatial, it can be heavier data sets, or it can be a very complex data preparation workflow with more than 500 tools. Or we are increasing the number of reports being shared throughout the gallery. So the whole idea for us to start scaling the gallery is that we want to improve the interface responsiveness, but also we want to provide our developers, the ones that are creating all the workflows, ways of collaborating. So it's always related to the web nodes there. So for us to provide, once again, more seamless user experience for everyone there inside our gallery. And of course here, this is something that we are going to talk more about during our next session. But the idea is that for you to add a new gallery or to add a new controller to your server, it's very simple configuration. So the only thing that you need to start connecting those components there inside your own environment is for you to have your controller token here. So this is the token that is used for you to start connecting your designers to the server scheduler, to start connecting your controller to your galleries, but also to start connecting your controller to your worker nodes. So that's why we have here a very large text here in red for you to, that's not advised for you to regenerate your control. That can break everything there, all the communications between your controller and all the components that you may have there, okay? So that's one thing that you always need to be aware when using that controller token or sharing that to a specific user. If you regenerate, if you change that token, everyone will lose connection to the controller. And also for you to install a gallery node is the same way as you would do installing the Alteryx server, but only selection that you need to do here is the custom one for you to enable the gallery here. So when we think about the load balancing, so every time you want to increase the number of gallery nodes, you need to use a load balancer to achieve that. So of course, the benefits are that you are distributing your workload, your incoming traffic. You are avoiding overloading any part of your system. You are improving the user experience. You are maximizing throughput. So the load balancer is responsible for deciding which gallery will receive that request. So once again, avoiding resource overloading. Avoid overloading one gallery node. And of course, if one of the gallery node goes down, the other one will assume, and the user will not perceive that. So the idea here is for you to have all of your resources as efficient as possible. But that being said, you need to start looking for load balancer options. So I have two here that I've seen Alteryx environment using those. The first one is the AWS Elastic Load Balancer. That's a great one for you to start using. It does everything there automatically, everything that I'm talking about here. You also have the F5 networks one. And that's something that you just need to be mindful, that you always need to have a load balancer for you to be able to have multiple gallery nodes, okay? But of course, last but not least, actually the most important one is to scale workers. So what do we start, do we need to think about when we are scaling workers? So we have a few questions here. So of course, we need to check how many users do we have, how many workflows, the type of the workflows, and how long that workflow takes to run, and how all that is going to be in a year, how it's going to be in 2 years. Will I increase the number of users, or will I start limiting everything there? And as I get everything answered here, as I get all the answers, then I can start thinking about, so now, okay, so I have everything on my hands. So how should I increase load? Should I scale in, add more cores to my single node environment, or should I scale out to add one more server machine as a worker? And of course, when we think about that, we need to always keep in mind what is our actual budget, right? So since the worker are the one that's doing all the hard work here, so we always need to keep in mind what is our actual budget for this project or for this part, for example, right? And when we talk about workers, we talk about very briefly about the engines as well. But the rule of thumb there is that one workflow can be run per engine. So it's a one-to-one relationship there. One workflow is running one engine. The more engines you have, the more simultaneous jobs you have also. But when you talk about the worker is that it's managing all the engines. And this specific worker can manage multiple engines. So one worker can run as many jobs as you have engines. So it's one too many. The only problem here is that, of course, you can have a worker node with tons of engines, but then if you start adding more than 2, that's the best practice there. And you will see that in our the benchmark testing results. You will start experiencing problems related to its performance. So maybe you start seeing a lot of workflows on the queue, or your workflow that used to take 5 minutes to run is taking now 10 minutes to run, only because you add too many engines. So when we think about worker, we have 2 options there. The first one, of course, I told you already, the scaling up. So we are increasing the number of engines here. So we are increasing as well the number of cores. So if you think about the best practice there, the idea is that for each 4 cores, we can use 2 engines. So if I add 4 more cores, an 8-core environment here. So I'm able, if I'm using, of course, best practice, to run 4 workflows simultaneously. Of course, if we scale up, we'll limit the amount of servers needed. So it's less cost of hardware. But the idea here is, okay, so you are using the same environment to run all the workflows, but also to run all the requests for our database, everything related to the gallery, So as you can see here, you are increasing the amount of memory, the amount of CPU that your single nodes are already using. So maybe you have a lot of memory that's should be used on the gallery. It's being used for one of the workers, and that can be a problem, right? So one of the options there is for you to start scaling out. So instead of having 4 engines inside your single node environments, just add another server, and you can see this one another server machine as a worker node. And as you can see in a benchmarking, you see that this has better performance, better throughput. And even having more costs involved, more hardware costs involved, you have better results there. You have much better results related to its performance, but it also gives you the ability to separate your workflows. So for example, if you have the one that I mentioned earlier, so you have a heavier data set or a team that uses only heavier data sets, or the data science team that uses very heavy predictive workflows. So that's when you can start thinking about separating one specific worker for those users, right? So when start to think about scaling, this, of course, once again, these guidelines for you to understand, it's all based on the complex of your workflows. So you can have a workflow here. You have 20 simultaneous users. You can have workflows running in 5 seconds, as well as you could have workflows running in 2 minutes. But maybe you need to be aware also of the cadence in scheduling workflows. So maybe you have 9% of your workflows are being run at the same time every day. And spreading that cadence will help you mitigate the needs for scaling. Of course, scaling is always a great solution for you, but maybe if you start checking what the users are actually doing in your server, maybe you will find ways for not scaling, for example. Of course, as your server grow, you start the need for testing everything that is happening. And once again, since everything is very particular to the workflows that you are running, to the amount of users, and to what actually the users are able to do inside the analytical apps, that's always better for you to test with your own data, with your own workflows. And you are the one that need to decide what works best for your company, right? So one thing that's great about the controller is that it's a hub and spoke model. So what that means? So that means that the controller have no idea about the workers. So you can have multiple workers attached to that controller. The only thing there that you actually needed is that controller token, and it's actually the worker that is doing all the requests there. So the worker is responsible for asking for the job with all the additional configurations. So for example, that specific worker can only run critical jobs, or can only run jobs from a specific studio. So it's the responsibility of the worker to give the controller that specification. For then the controller to send one of the jobs from the job queue that's going to be being managed here to a worker nodes. So that way, and that also happens for the gallery nodes. So the controller doesn't know about anything. So it's very easy for you to scale, and also dynamic scaling. So you don't need, so if you have a worker and the worker is down, so you don't need to restart or shut down your controller for that worker to start working again, to start running workflows. And once again here, the ways for you to configuring that controller is using the controller token. And also, once again, is strongly advised not to regenerate your controller. And it's the same basic idea. So if you have your controller token, you only need to select this to enable that machine as a worker node. And then this machine starts asking for the controller for jobs, for new jobs to be run. But let's go ahead to the benchmark testing. What we're going to be testing here, so it's actually how many instances of engine is allowed simultaneously. Of course, I'm always saying here that we can run 2 workflows at the same time, but let's show you some results related to that. So how many instances should I move to other machine? Should I focus on scaling up or scaling out? So you have a lot of different types of workflow, IO intensive or CPU intensive. And for the CPU, you have spatial processing, and for IO, you have large data sets. And also using a lot of memory intensive for the large data set joins. All right, so that's what we're going to be testing today. And the whole idea for this test is to analyze 2 main indicators here. The workflow throughput, is that the number of workflows that is run by the total runtime. So it's the number of workflows per minute. And the engine throughput is the number of workflows per the usage of the engine. So the idea here is that the higher the number, the more workflows are being processed, and the more workflows are being processed by the engine. So the goal is always to maximize both, okay? And the second one, actually, the engine one is the one that's a little bit hard for us to understand what is actually happening. But the idea here is the lower the value there, the more time another workflow is waiting in the queue, waiting to be processed. So the idea, imagine you have a user there that's trying to run anything manually using the gallery. And he press the run and start, for example, it waits 5 minutes there because maybe your engine throughput is lower or is slow. That's why you have a lot of workflows waiting in the queue. So we have here, for this case, we have one workflow that runs in 4 to 5 minutes. It's IO intensive. Another one, CPU intensive. And we are using both workflows here, and it's queued five times. So the idea is that we are running 10 workflows. It's like 50 minutes there. And we are using the average to check how many workflows is being run per minute. So we are using here a 4-core machine with 32 gigabytes of RAM, SSD, and 1 physical disk, Alteryx installed in SSD, and everything else installed in the spinning disk. And let's see the results here. So for the first one, so we are using actually a suboptimal scenario. So the best practice is that one worker can run 2 engines at the same time. So let's start using one engine. So what you can see here is that it runs smoothly. So the idea is that the machine is not taxed. So the engine and workflow throughputs are identical. Let's move to the second scenario. So the idea here is that now we are using 2 engines. So the ideal scenario, the recommended scenario. And as you can see here, so now the worker is able to give more results, double the results as they would if have only one engine. So we're actually able to run 2 workflows at the same time without losing anything here on the engine. So this is the ideal one for us that we always use as best practice. But let's take a look if we start including more engines there. So as you can see here, the number of workflows that's being run per minute are basically the same, but you have here a lower engine throughput, which means, once again, more workflows in the queue waiting to be processed. Let's add more. And as you can see here, it's actually start to run slower, both for the engines and the worker. And you can see that all engines are resource starved. Engines are much more slower than 2 workers. So that's why we always leave as a best practice to use 2 engines per worker. So that's what that is coming from. So of course, you can produce a little bit more using 4 engines, but as you can see, you have more workflows on the queue. So it's always best for you to run everything faster with only 2 engines, because for the end user experience, it will be a lot better. But that was actually a configuration where we are scaling in. So we are adding more engines to the same environment. But let's start scaling out. So adding workers and engines to a separate machine. So the whole idea here is that we have a new machine here, a 4-core, 16 gig RAM, and everything's the same for the SSD part. Alteryx installed on SSD, everything else installed on the spinning disk. And the idea here is that, as you can see, for the same amount of workflows being run, so 4 engines and 2 works with 2 engines each is running the same amount of workflows, but as you can see here, it's almost doubled. So from here, so if you include more engines in a separate machine, you will be able to run 2 times faster. So that's why scaling out is actually better than scaling in. You see here that your engine is great. It's almost in its high performance, but you are actually getting more results from your workflows here, almost double the results from the first example. And this is best practice as well. So best practice here and best practice here when dealing with 2 workers. But let's start now adding one more component to this test. And it's actually for you to run everything on SSD. And instead of talking a lot about what is actually happening here, let me show you the actual results. So one thing that you always need to be aware, so see here, so we are using 1 worker with 2 engines, the best practice, but we also are using here for an SSD environment using 4 engines per worker. And as you can see here, when you start thinking, if you have the whole environment with SSD, it's actually better for you to have 4 engines. So look how amazing this is. So the idea there is that it's always related to your own environment. You always need to test it. Of course, we have that best practice that says that 2 engines per worker is ideal. But as you can see here, for the worker, for the workflows that we use for this testing, it's actually better for you to have 4 engines. So that's one thing that always need to keep in mind. All right. So moving forward, actually, I have one more test that I want to show here. It's more basic, but it's related to the AMP engine. So the AMP engine is the new engine that Alteryx has created. So for now, you have the possibility to selecting the A1 engine in both the AMP. And the main difference in there is that the AMP1 use multi-threading processing. So it's actually run in more cores. All the cores that you have there, the AMP engine will be using. So the test here is much more simple, but it's only one idea for you to have when you are thinking about using the AMP engine in your own environment. So the only difference here between the tests is that you have 2 instances of the AWS here. and you have the worker is already scaled out. You have 4 cores, 16 GB RAM, and you have running here 3 types of workflows. So data prep, spatial, and predict analysis. Also, one with the single thread engine and another one with the multi-thread engine. And here are the actual results. So this is on the server, Alteryx server. So as you can see for the Alteryx gallery, look how fast it ran. So it took for the A1 engine almost 3 minutes, as of the AMP engine almost 2 seconds. And as you can see, of course, we have difference related to the spatial, and for the predictive, we don't have much gains here. But the idea there is that you can always think about leveraging the AMP engine. But one thing that you always need to be aware here, so in this benchmark testing, it was used only one workflow at the same time. So it haven't been tested to use 2 workflows or, for example, 2 engines, 4 engines, because since that one workflow is using all the cores, so all the 4 cores, maybe you need to really be aware of when you want to use the AMP engine in your own Alteryx server. So maybe you have some data prep workflows there in a specific worker node that you want to run a lot faster. So maybe that worker node can use the AMP engine. But as a standard, it's not ideal for you to always have the AMP engine there enabled, because maybe you can start using or starving the engine resources there, the same way as you would when you are using 6 engine with one worker only. All right. So that's one thing for you to always keep in mind there when using the AMP engine within Alteryx server. Of course, when you are in Alteryx design, it's recommended for you to always use the AMP engine. Of course, maybe it will not run fast for predictive, but for prep and blend and spatial, most definitely will. So how can we identify scaling needs? So we have here actually, and we are going to talk about this in our during the next sessions. So it's related to how to identify scaling needs. We are talking about the Alteryx server usage report that you all have access to. You can download this in the licensing portal together with the Alteryx server installer. But the idea here is that you have the whole view, the overview of everything that is happening inside your private gallery. So have everything related here to the users. So when the users are logging in, so have here, actually it's separated only by time, but you can see here the number of logins per day as well. The login history, you can see how many users we have in any of the studios here. So the idea here, so okay, so maybe I need to scale my worker or my gallery. So the idea here is that if you are seeing a lot of logins the whole day, maybe it's time for you to start thinking about scaling your gallery. Or maybe it's time for you to start thinking about scaling your worker as well. So look at here, how crazy this is. But also here, so here is related to the users. You can also be aware of the contents, everything that's been shared on the studio. So how many workflows you have in a specific studio. So for example, take a look here for the data science one. So maybe it's time for us to create or to scale out a worker and to give them personal access to that worker only, since we have a lot of workflows here, and it usually takes a lot of time for the predictive modeling workflows to run. So maybe it's time for us to start thinking about scaling out to give the data science team a specific worker for them to start running their workflows. Also, related to jobs, so you can see all the workflows here. So how many minutes the workflow is taking to run. So we have here a whole view of the runtime, the number of times it was run, and the how many seconds or minutes the workflow is staying on the queue. As you can see here, we don't have a lot of workflows on the queue. So that should be fine for us to start to keep using the same amounts of workers or the same amounts of components that we currently have. All right. So that's one way for you to start analyzing your jobs and everything that is actually going throughout your day. One other thing there, and the last thing actually, this is the schedule forecast page. Is you have access in your Alteryx server already. Of course, this is the admin part of the Alteryx server, and we will be talking about this during our administrative session. But the idea here is that you can forecast everything that is happening inside your gallery. And as you can see here, it's all color coded. You can see that here we have 6 jobs. This is related to a 30-minute slot. And the idea here, for example, so if you have a single node environment, if one worker, 2 engines, so we have a runtime capacity here of 60 minutes for each 30-minute slot. If I have 6 workflows scheduled and a total runtime for those workflows of 30 minutes, and you can see the runtime here as well, then if we divide here, we have the capacity of half being used. And the idea here is that you have this color-coded chart, and then you can start thinking about, for example, moving this job to another day or another time or another slot. So that's the whole idea here. So before scaling, you can also start checking what is happening with your users, with your workflows, and with everything that's being run on the gallery. Of course, lastly here, I'm going to be very quick because we don't have a lot of time, but I have some tips and tricks for workflow optimization. So it's basic, but it's always great for us to start saying is that you always need to be using the select and the filter tool to remove any unnecessary data that you have there as quickly as possible. So the first tool that you need to have there is a select tool, remove all the columns, remove all the nonsense that you have there as well. And also, if you are using the filter tool and you have, for example, a complex condition with a lot of scenarios there, instead of using only one filter tool with a complex condition, is always better. Of course, if you are capable of doing that, use serialized filters. That will run a lot faster, especially with larger data sets. Always use the auto field to automatically select the smallest and most efficient field type. And the idea here, of course, it takes a lot of time for you to run the auto field, but you have one specific process where you use the auto field to create actually the whole suggestion for the most efficient field types, and then we remove the auto field from the workflow. So that's the whole idea. And also to use find replace instead of using join. Of course, this only related and when you only need the join anchor or the join or the left join anchor. But the whole idea here is that if you have small lookup tables coming from your right input anchor, so it's always faster for you to use find replace instead of join. And always be aware of Alteryx blocking tools usage. So the idea with blocking tools is that before the data outputs that tool, you need to read everything and put everything on the memory or put everything in temp files. And what is a blocking tool? It's actually, you have the periodic table of Alteryx tools. Everything here that is red, it's actually a blocking tool. All right, you can find here, so you can Google it, search it, and you can find this. And you have a lot of information related to all the tools that you may have here. And the performance profiling. So analyze the time for every tool that you may have there for you to start understanding what is actually happening there. So maybe you have, as you can see here, we have a lot of browse tools. That's when you go to the server, you don't need to be worried about that, but maybe you need to start worrying about this tool. Maybe if you use a select first, you improve the time that this tool is currently being used. And that's it. I think it's 1 o'clock already. Let me check here if you have any questions. Actually, Thales did a great job there, answered everything. I hope that you guys enjoyed the session as well as I did. And thanks a lot for attending. We have our next session that's going to be covering everything related to the installing and deployment of your Alteryx server. It can be a single node. So if you don't have that installed already, we can help you and to configure everything that you have there, as well as some tips and tricks that we are more than welcome to share with you guys. So thanks a lot for attending, and I hope that you enjoy the session. Thanks, everyone.
If you have any questions or suggestions for future videos, please comment below. And don't forget to subscribe to know when future videos are posted.